questions. Most of the questions, whatever we are discussing today, sir, from where the questions we have picked it up. Now, today's questions, sources. Sir, from where these sources are there? Sources. Good number of questions are picked out from the bank previous year questions. Good number of questions are picked out from the previous year bank questions, and good number of questions are picked from the Staff Selection Commission previous year questions. Good number of questions are also picked out from the CAT/IP/MAT previous year questions, and also I have taken few examples which are from the previous placement papers. So entire source of the questions, in case if you are a student who belongs to any of these category, in case if you are a student preparing for defense, railways, insurance, civil services, aptitude related examination, in case if you are a teacher who take aptitude coaching classes, must attend class. These are the sources from where the questions are picked it up. What we will do is, we will take the question you will find it in Google. What I will do is, I will take the traditional method. If you are an Anil Nair student, what you should learn and how you should solve the question in less time and less number of steps. There will be method 1, there will be method 2. Method 2, it is exclusively for the Anil Nair YouTube channel subscribers as well as the Anil Nair app downloaded students. Sometimes I will keep the class in an unlisted mode and I will just send a push notification only to the app downloaded students. So ensure that you download the app and check the top right side, one push notification bell icon will be there. Regularly check all the notifications. I hope you are all ready for the class. Let us get into an scintillating class on how to solve simplification related problems through multiple concepts. These are the sources of the questions. Bank previous year, PYQ means previous year questions. Staff Selection Commission previous year questions. CAT/IP/MAT is IP/MAT. In case if you got an younger brother or an younger sister studying in +1 or +2, there is a golden opportunity for them to get into an IIMs by directly writing an entrance test. That is IP/MAT entrance test. In case if you want to know, sir, I want to know the details, it will help my younger brother or younger sister, please send a message to this number requesting for an IP/MAT PPT. That also we will do it. Now first question. Now see the first question. What is important to me is not the traditional method, but the approaches you will learn. First, I will start with a very, very easy question, but I wanted to teach you some concepts. Read the first question. Again, I am telling you, original class notes, PDF, you will get it in the Telegram group. Question is 148 divided by x into 62 equivalent to 248. 148 by x into 62 equivalent to 248. Very, very easy way to solve. Almost everybody will get this answer. 148 by x into 62 equivalent to 248. How you will solve the question? 62 ones are 62 fours are 248. 4 ones are 4, 3s are 12, 4 7s are 48. X equivalent to 37. Almost 100 out of 100 students will do this approach. I am not interested to teach something you already know. For me, what is important is some concepts. Listen carefully, sir. First concept, 12 into 3 equivalent to 36. 12 into 3 equivalent to 36. Listen, sir. 36 is divisible by 4. 36 is divisible by 4. 3 is not divisible by 4. So 12 should be divisible by 4. 12 should be divisible by 4. Forget about this question. From the question, we will learn the concepts and we will create live questions in the spot from the concepts whatever we earned. I am not interested in solving questions. I am interested in igniting the minds by discussing beautiful concepts which are hidden through the questions. 12 into 3 equivalent to 36. 36 is divisible by 4. 12 is divisible by 4. That means if the answer is divisible by 4, this is not divisible by 4. This should be divisible by 4. This should be divisible by 4. Are you all with me? By using that concept, what is the divisibility rule of 4? Last two digits should be divisible by 4. What is the all the important key points? I will write down in the digital board so that you can go through the PDF also. Divisibility rule for 4 is last two digits should be divisible by 4. Last two digits should be divisible by 4. 248. 48 is divisible by 4. Right hand side is divisible by 4. This is not divisible by 4. That means 148 plus x. It should be divisible by 4. Are you all with me? 248 is divisible by 4. 62 is not divisible by 4. 148 by x should be divisible by 4. Next one, another one. 148 divided by 37. 37 4s are 148. 4 is divisible by 4. There is no option more than 1. So option is 137. It's a very, very simple problem which you can solve it by doing 62 4s are. What if the number of digits are 4, 5 and 6? Can these logic be used to solve a lot of problems? Yes. Please write down the star mark, then we will see. Divisibility rule for 4 is last two digits should be divisible by 4. Last two digits should be divisible by 4. Now listen carefully. The same question can also be asked in algebra like this. 3x plus 6y equivalent to 1, 2, 3, 4. 3x plus 6y equivalent to 1, 2, 3, 4. xy are natural numbers. How many values it will take? xy are natural numbers. How many values it will take? Looks like a question which involves counting. See here. 3x is divisible by 3. 3x is divisible by 3. 6y is divisible by 3. 3x is 3 into something. It is divisible by 3. 6y is divisible by 3. If I add two numbers which are divisible by 3. If I add two numbers which are divisible by 3. 9 plus 12, 21. 9 is divisible by 3. 12 is divisible by 3. 21 is also divisible by 3. 15 plus 18 is 33. 15 is divisible by 3. 18 is divisible by 3. 33 is divisible by 3. This is divisible by 3. This is divisible by 3. 1, 2, 3, 4 should be divisible by 3. What is the divisibility rule for 3? Sum of the digits should be divisible by 3. 4 plus 3, 7. 7 plus 2, 9. 9 plus 1, 10. 10 is not divisible by 3. 10 is not divisible by 3. Therefore, how many values x and y will take? No value x and y will take. No value x and y will take. I have seen a lot of teacher question and solve it. Question and solve it. In the question, the concept which can be used. We will create questions on spot. You will understand what if an author takes the class and the tutor who has gone through R.S. Agarwal problem solving 3 times will take the class. I hope this is the concept. Divisibility rule for 4 is last two digits should be divisible by 4. These divisible by 3, divisible by 3. 1, 2, 3, 4. Sum of the digits is 10. If the sum of the digits is divisible by 3, then the answer is divisible by 3. 10 is not divisible by 3. This is a simple clerk related question. This is a little typical SSC related question. If the same question is asked in CAT, the idea remains the same. Idea remains the same. Question is, there is a person who is giving, 500 rupees, 500 rupees using 5 rupees, 20 rupees and 50 rupees. And that too, he has to use exactly 20 notes. He has to use exactly 20 notes. Exactly 20 notes. There are 5 rupee notes, there are 20 rupee notes, there are 50 rupees notes. Totally that person has to give 500 rupees to his friend, and the condition is he has to use exactly 20 notes. The same divisibility rule, how it is asked in CAT exam, we will see. We have seen how it is asked in CMAT and other SSC related examination, how the concept can be used in clerk related examination. This is the beauty of thematic based learning. Now see here, this is the question. Most of the students fear looking at this question because the question seems to be like a counting. Method 1, they will count it. Method 1, they will do the counting method. Method 1, they will do the counting method. The mistake which they will do is, sir, 5 rupees are there, 520s are 500s are 500. 100 notes I am taking, but how many notes I should take? Exactly 20 notes I should take. That case it is not possible. If I take only 20 rupees notes, 500 by 20 is 25. 25 notes I should take, but I need to take 20 notes. Like that, if you do only 5, only 20, only 50, 5 and 20, 20 and 50, 5 and 50, 5, 20 and 50, this many cases you have to take. Method 1 is not considered to be the ideal method. Now method 2, logically we will solve, sir. Logically we will solve. So let the number of notes of 5 rupees are x. 5x plus 20y plus 50z equivalent to 500. So 5 is common in both left hand side and right hand side. X plus 4y plus 10z equivalent to 100. Totally how many notes I am using? X plus y plus z equivalent to 20. So this will be 3y plus 9z equivalent to 80. 3y plus 9z equivalent to 80. Now 3y plus 9z equivalent to 80. Just now we have solved. 3y, it is divisible by 3. 9z, 9 is divisible by 3. 80, it is not divisible by 3. 80, it is not divisible by 3. So how many ways are possible? There exists no way where you can give 500 rupees by using exactly 20 notes of 5 rupee, 20 rupees and 50 rupees. 5 rupee, 20 rupees and 50 rupees. I need to use exactly 20 notes. Beautiful question, first one. Beautiful way of looking at this question from the divisibility rule point of view. Divisibility rule of 4. How it is used in various examination, right from an basic examination to a toughest examination. A classical example. I hope the idea it is clear. I hope the idea it is clear. Abhiram asks a question. What is the divisibility rule of 3? Divisibility rule of 3 is sum of the digits should be divisible by 3. Sum of the digits. In case if you are in doubt, divisibility rule for 3. Divisibility rule for 3. Divisibility rule for 3. XYZ in base system 10. This is for Abhiram. XYZ in base system 10. Units place, tens place, hundreds place. So it is 100x plus 10y plus z. There is a face value and there is a place value. X is there in units, tens, 100. X is there in hundreds place, Abhi. So the value of x will become 100x. Y is there in tens place. So the value of y will become 10. So this can be written as 99x plus 9y plus x plus y plus z. X plus y plus z. X, Y, Z based on. If the left hand side is divisible by 3, if the left hand side is divisible by 3, 99, 9 into 11 divisible by 3, 9 into any number divisible by 3, x plus y plus z, it should be divisible by 3. X plus y plus z. X plus y plus z is the sum of the digits. That is the reason, Abhi, the divisibility rule for 3 is sum of the digits should be divisible by 3. Sum of the digits should be divisible by 3. Sum of the digits should be divisible by 3. I hope the concept is very, very clear. Example 2a1, it is divisible by 3. Find the values of a. 2a1, there is a number 2a1. There is a 3-digit number with the leftmost value 2. There is a 3-digit number where the middle digit it is not given. It is divisible by 3. So that means 2 plus a plus 1 should be divisible by 3. 2 plus 1, 3, it is divisible by 3. A can be 0, A can be 3, A can be 6, A can be 9. A can take 4 values. Why? Because 2 plus 1 is divisible by 3. A should be divisible by 3. A should be divisible by 3. So A can be 0 or any multiples of 3. 3, 6 and 9. A can be 0, 3, 6 or 9. A can be 0, 3, 6 or 9. Abhi, I gave a proof for you why it should be divisible by 3, and I gave an example for you how to use the divisibility rule for 3 for your doubt. I hope it is clear. Right? Jnanaranjan is asking, if the right hand side will be divisible by 3, then what to do? Suppose A plus B is divisible by 3. A plus B is 15. If A plus B is 15, there are multiple cases that will come. These for you, Jnanaranjan. First case, A and B, both are divisible by 3. Both are divisible by 3. 3 into A plus 3 into B. Both are divisible by 3. Case number 1. 3k1 plus 3k2 equivalent to 3 into something. 3 common. Case number 1, if it is clear. Case number 2, A can give remainder 1. B can give remainder 2. When you divide a number by 3, what are all the reminders you will get? 0, 1 and 2. When you divide a number by 3, you will get the reminders 0, 1 or 2. A can give remainder 1, B can give remainder 2. Add it, Jnanaranjan. 3k1, 3k2, divisible by 3. 1 plus 2, 3. It is divisible by 3. Case number 3, reverse can also happen. A is 3k1 plus 2 and B is 3k2 plus 1. Either this case or this case. Case 1 or case 2 or case 3. I hope I answered your question. Right? But you said 3x plus 6y concept also explain. 3x plus 6y equivalent to 1, 2, 3, 4. 3x it is divisible by 3. 6y divisible by 3. Left hand side both are divisible by 3. Right hand side should be divisible by 3. Sum of the digits should be divisible by 3. 1 plus 2 plus 3 plus 4. 10 is not divisible by 3. 10 is not divisible by 3. Therefore, answer is no value. First question, I hope the idea it is clear. Second question. Second one, see here, sir. Root of 7569 minus root of 3136 equivalent to 868 minus root of 7569 minus root of 3136 equivalent to 868 minus. We will solve this problem by understanding few concepts. Listen carefully, sir. Concept. First concept. Concept 1. Key point 1. How to find out the square root of a perfect square. How to find out the square root of a perfect square using last two digits. How to find the square root of a perfect square using the last two digits. Very, very interesting logic. This is how most of the students will solve it. Then we will see some other better approaches. Some other better approaches also we will see. First we will do it in a traditional method. Square root of a perfect square using last two digits. What is the concept? X square 50 into natural number plus or minus x whole square. 50 into k plus or minus x whole square. Last two digits will be same. X square 50 into natural number plus or minus x whole square. Last two digits will be same. Last two digits will be same. In the previous classes, we have seen that concept. Step number 1, 69. These how students will solve. 69. 13 square is 169. What are the other numbers? 50 plus 13. Next number 50 minus 13. Next number K2 100 minus 13. 87. 80 square is 6400. It is greater than 6400. So this answer is 87 minus 87 square minus root of 3136. Root of 3136. 6 square is 36. 6 square is 36. 50 minus 6. 50 plus 6. 100 minus 6. 50 square is 2500. 60 square is 3600. So it is 56. 87 minus 56 equivalent to 868 minus 868 minus. Now please do not solve this number. 7 minus 6 is 1. Something minus 8 minus 7, it is 1. 8 minus 7, it is 1. This is not possible. This is not possible. This is not possible. This is not possible. I hope the idea it is clear. So this is 31. 868 minus 31. 837. This is how 99% of the students might have solved it. What they did is they found out the square root of this number, they found out the square root of this number, and they did 87 minus 56 equivalent to 868 minus. Very good method, perfect way to solve this problem. But whenever this kind of questions are given, first do a step, then get into this step. This step is absolutely right logic, sir. Absolutely right logic. 87 square is 7569. 56 square is 3136. 868 minus. Find out this value, find out this value. Do subtraction of this value, you will get the answer. Unit digit can help you to eliminate incorrect answer options. 7 minus 6 is 1. Left hand side unit digit is 1. 8 minus 7, it is 1. 8 minus 5, 2. 8 minus 6, 2. 8 minus 0, 2. That is the reason I eliminated. Very good logic. Definitely you should know this logic. But in case if it is given in examination like this, square root of 7569 minus square root of 3136 equivalent to, how much is the number? 868 minus 868 minus. This is the question mark. Root of 7569 minus root of 3136 equivalent to 868 minus. Suppose if the options are like this. Options are like this. Sometimes the answers are so stupid. 837, 836, 842 and 848. Assume options are like this. 837, 836, 842, 848. First thing is concept. You are not here Please do not waste your time in writing the answer. I am least bothered whether you got the answer or not. My worriment is, are you knowing the approaches which you do not know till now? So don't feel happy by getting this answer. If I am teaching something in the class, that is something which will help you with a lot of variety of problems. Concept: square root of even number. Square root of even number is always an even number. Root of 16 is 4. Root of 36 is 6. Root of 1225, it is 35. Square root of odd number. Square root of odd number, it is an odd number. First thing, make a note of it, sir. Root of even number is an even number. Square root of odd number, it is an odd number. This will help you to eliminate some wrong answer options. At the end of the class, I will give a table which method you need to use it. Now see here, listen carefully. 7569, it is an odd number. Square root of odd number, it is an odd number. Root of 3136, it is an even number. 868, it is an even number. Odd minus even is odd. So even minus, it should be odd. Even minus odd only can give you odd. Answer should be an odd number. Answer should be an odd number. Answer should be an odd number. Please write it down in your notebook. If the answer options contain even and odd number, if the answer options contain even and odd numbers, first 5 seconds, use this logic and eliminate. Now see here, please write down in your notebook. Write down in your notebook. Write if the answer options. If the answer options. If the answer options. If the answer options has even and odd numbers. If the answer options has even or an odd number. If the answer option has an even or an odd number, then please eliminate all the concept way based on number tree. The first concept which everybody should know is number tree concept. In number tree concept, 2 concepts which we discussed. One is even and odd, and another is divisibility rule. Write down in the same order, sir. Divisibility rules, even and odd number, and the next concept is divisibility. Right? Divisibility rule. Divisibility rule. I hope the idea it is clear. Just write down, sir. I am just instructing my team to block the students who are time wasters to me. Next, please write down. I hope this concept is clear. Next, square root of 7569 minus root of 3136 equivalent to 868 minus. So these 3 options are eliminated. This is one way to look at it. Sir, what if there is another option? 827 and 847. 827 and 847. There could be a case of having 837, 827 or 847. 827, I think there is an option. 887. How to eliminate it without even solving these? How to find out the square root of a perfect square? Can I look at a question and can I eliminate the answer options? If there is any answer option which is an even number, just eliminate it. In case if you got an odd number, let us do it. Let us do it. Please write down, sir. Please write down. This is a pure bank related question. Square root of 7569 minus square root of 3136 equivalent to 868 minus question mark. 868 minus question mark. Options are 837. There is one more option. 887, 847 and 867. 837, right? 837, 887 847, 867. If more than one answer option is an odd number, how to solve? Now listen carefully, sir. Let us not find out the square root of a perfect square. What is the logic that we discussed right now? This is a very important logic. X square 50 into k plus or minus x whole square. X square 50 into k plus or minus x whole square. Last two digits will be same. Last two digits will be same. Now listen. 7569. What are the last two digits? 169. Which number on square I'll get 169? 13 square is 169. That means the last two digits can be 50, 13, 37 or 63 or 87. These are all the possibilities. On square, I will get the last two digits same. Similarly, 31, 36. 6 square is 36. 50 minus 6, 50 plus 6. 100 minus 6, 100 plus 6. 100 plus 6. Are you all with me? So, these square root of 7569. It is 87. 31, 36. It is 56. It is 56. From there, you can find it out. 87 minus 56. How much it is? 31. 31. 868 minus 31 I require. Only focus is on last two digits. Only focus is on last two digits. Only focus is on last two digits. I hope the idea it is clear. Only focus is on last two digits. See, 868 minus 37, 31. 68 minus 87, not possible. 847 also not possible. Now 1 minute, sir. 1 minute. 1 minute. These also you don't need to do it. 36 is divisible by 4. So it is 4a. It is an odd number. Odd number on squaring. I will get 4a plus 1. 868. It is 4k minus something. So answer should be of this form. I hope the idea it is clear. This I will do it after solving some fundamentals. I hope this concept is clear. 69 is 13 square 169. 13, 37, 50 minus 13, 100 minus 13, 50 plus 13, 50 minus 6, 50 plus 6, 100 minus 6, 100 plus 6. After there, 7,500. This. That's how we did the traditional method. There is a beautiful concept of divisibility rule of 4. Divisibility rule of 4. That will also help the answer. I don't know if you are able to take that logic, but still, I will try to introduce that divisibility rule logic. Divisibility rule logic. Listen carefully, sir. LHS and RHS. RHS it is 868 minus. 868 minus. If I take 837, it is 831. Check whether the left hand side divisibility rule and the right hand side divisibility rule all are 7. All are same. All the answer options are odd only, right, Vinil? That is what I am explaining. 837, 887, 847, 867. Did you see any number which is an even number? First thing, this is 87. This is 56. 87 minus 56 is 31. Last two digits is 68. 68 minus 37. 68 minus 37. What will be the answer? 31. So these eliminated. These eliminated. These eliminated. I hope the concept is clear. You can also use the divisibility rule concept. But this is a level 2 problem. I'll solve the level 1. Then I'll get back to this problem. Here it is 87. Here it is 56. 87 minus 56 is 31. 68 minus 37 is 31. You do not need to add both these number and subtract it from a last two digits. If the number of digits in a number are more, if the number of digits are more, just play around with the last two digits. Just play around with the last two digits. I hope the concept is clear. I hope the idea it is clear. Next one. Next one, sir, why are you emphasizing on the last two digits? By knowing the last two digits, you can get these answer. Listen carefully, sir. Listen carefully. 108 square plus 35 square minus 99 square. 3542, 3178, 4188, 3088 and none of this. 3088 and none of this. Now see here. Last two digits are different for more than two answer options. Last two digits are different for more than two answer options. I hope it is clear. So 108 square. 108 square can be written as 100 plus 8 square. 100 plus x square and x square. Last two digits will be same. 8 square it is 64. 35 square, even 5 into even 5. Last two digits is 25. Last two digits is 25. 99 square. 99 is 100 minus 1 square. Please do not find 108 square, 35 square, 99 square and waste your time. 100 and minus 1 square, it is 01. So it is a plus sign here, it is minus sign. 64 plus 25, 89 minus 1, 88. 89 minus 1, 88. Only first option, second option we eliminated. We still need to do 3, 4 and 5. We still need to do 3, 4 and 5. 108 square. What is the logic which I am using? X square, 100 plus x square. Last two digits it is same. 108 square is 100 plus 8 square. Last two digits is 8 square, 64. 35 square. Even 5 into even 5. Last two digits is 25. 99 square. 100 minus 1 square is 1. 64 plus 25. 89 minus 1. 88. Answer last two digits it is 88. First option and second option only can be eliminated. Then coupled with, let us use digital sum concept. Let us use digital sum concept. Let us use a digital sum concept. And we can also use the divisibility rule concept. We can also use the divisibility rule concept. These are all the concepts which will help us in eliminating answer option. Whether it is a digital sum, whether it is a divisibility rule, totally, I think next slide, totally, these are all the concepts to eliminate incorrect answer options. To eliminate incorrect answer options just by looking at a question to tell whether this answer is definitely wrong. To eliminate incorrect answer options. To eliminate incorrect answer option, what are the various methods that can be used? One is unit digit logic. If the answer options unit digits are different, use these logic. I am repeating again. If the answer options unit digits are different, use these logic. If the answer option last two digits are different, use the last two digits logic. Use the last two digits logic. If the answer option can be eliminated by using divisibility rule, by using divisibility rule, use these concept. And even and odd, square root of even number, it is an even number. Odd into odd, it is an odd number. Even and odd number. Next one, digital sum. These are all the concepts which can be used to eliminate incorrect answer options. Unit digit, last two digits, divisibility rule, even and odd numbers, digital sum. If all these is eliminating few answer options and you are struck, then use speed calculation techniques. Then use speed calculation techniques. Speed calculation techniques needs to be used after using all these 5 tools. Kindly take a screenshot of this concept. Kindly take a screenshot of this concept. If the answer option, again and again I am telling you, sir, if the answer option unit digits are different, attack using unit digit. If the answer option last two digits are different, use the last two digits. If the divisibility rule, this is used depending on the merit of the question. even and odd number. These also used for the merit of the question. Digital sum. Digital sum. All these 5 will help you to eliminate incorrect answer options. Out of 4, 2 you eliminated it. Next 2 you are stuck. Then you can use the speed calculation techniques. Kindly take a screenshot of this. Very, very important. You will understand it thoroughly. Just now the simplification session 1 has just begun. Once we do session 1, session 2, session 3, session 4, hopefully by session 4, you will understand why Anil sir is using this concept and why is he not using this concept. Unit digit, last 2 digits, divisibility rule, even and odd number, digital sum. These are all elimination techniques. And once you are stuck, then you will go to speed calculation technique. Then you will do speed calculation technique. Let me see the technique. Let me see the questions. Please do not waste your time. I am telling again and again. If any student is so worried about the answer in the live chat, please do not watch my live classes. I am least bothered about you got it right, very good, keep it up. All that motivational lines, I will not use it. My motivation is to teach the concept. They are all the lines who are playing around, right, with your mindset. Learn the concept and move ahead. Sir, there are a lot of students who generally do not ask the question, why this option, why not this option? I wanted to teach you that way of learning, which is thematic based learning. Now we are stuck with 2 options. Now we will do digital sum. Now we will do digital sum. Right? 1 plus 8, 9. 9 square, 81. 8 plus 1, 9. Answer digital sum is 9. Wherever 9 is there, just eliminate it, sir. Wherever 9 is there, just eliminate it. 9 plus any number, the digital sum is equivalent to the number. 9 plus 4 is 13. 13 digital sum is 4. 9 plus 4, 4 is also added. 9 plus any number, digital sum will not change. 9 plus any number, digital sum of 32 and 23 are same. 9 plus any number are multiples of 9 with any number. Answer digital sum will not change. Answer digital sum will not change. I hope the concept is clear. 108 square, directly eliminate. 99 square, directly eliminate. 35 square, 9 directly eliminated. 35, 3 plus 5, 8. 8 square, 64. Answer digital sum is 1. Answer digital sum is 1. 8 plus 1, 9. 8 plus 4, 12. 8 plus 4, 12. So these eliminated. 3 options it is eliminated. When he is telling you none of these, what is none of these here? None of the 4 answer options. None of the 4 answer options. 3. 8 plus 8, 16. 16 it is. 16 digital sum is 1 plus 6, 7. 7 is the digital sum matching. Please check it out. The last 2 digits is 88. So first is out, second is out, 88. It is matching. 8 plus 1, 9. 8 plus 4, 12. 12 it is divisible by 3, but I want the digital sum. 9, 8 square, 64. Digital sum should be 1. Digital sum should be 1. Is 3088. Is it giving you digital sum 1? No. If it is not giving you, answer is none of this. If it is giving you, answer is 4. Answer is 4. I hope the logic it is clear. What are the concepts that we learnt in this question? X square, 100 plus or minus x whole square. Last 2 digits are same. Next one, what is the logic we used here? 3 is an odd number. Odd 5 into odd 5 or even 5 into even 5. Last 2 digits is always 25. I wrote only one case here. Even if it is odd 5 into odd 5 or even 5 into even 5. Last 2 digits it is always 25. I hope the concept is clear. Kindly reply in case if you have understood this concept. Otherwise, in case if you got a doubt, mention the doubt whatever you got. Whenever in our exam related question, when he is saying none, that means none of the 4 options are right. None means none of the 4 options are right. There is one more option that is possible. Not possible. That means you cannot find the answer to the question. Not possible means you cannot find the answer to the question. None means none of the four options are also right. Now, what is the option that Madhu is asking? Sir, if the fourth option 2188, suppose if it is 2188, if it is 2188, 2188. If it is 2188, how will we find the answer? Now see here. If we, let me write down his doubt. Question is 108 square plus 35 square minus 99 square. What is the option which he mentioned? This is 2188. This is 2188, his option. 2188. If it is 2188, what will be the answer? 108 square. In the previous class we discussed a square minus b square is a minus b into a plus b. 108 square, it is 8 is b. 108 minus 8, 100. 108 plus 8, 116. Plus 64. This is 11664. In the previous classes of speed calculation, we discussed some very good concepts of how to find the squares of a number. That is what Madhu I am telling. If you are stuck with all the 5 tools, then get into speed calculation. Odd 5 into odd 5, 25. A into a plus 1. It is 1225. 99 square. It is 9801. It is 9801. Generic speed calculation technique. This table is extremely important, sir. Unit digit, last 2 digits, divisibility rule, even and odd number, and digital sum. By using these 5 options, in case if you are getting 2 answers, then get back to speed calculation. Then get back to speed calculation. Then get back to speed calculation. I want to teach some more very, very interesting concepts in this problem. See here, sir. See here. Madhu has asked a doubt. Let me keep one more doubt. Suppose divisibility rule. For 4, let us use divisibility rule for 4. What is the divisibility rule for 4? Last 2 digits should be divisible by 4. Last 2 digits should be divisible by 4. 8 is divisible by 4. 4 9s are 36 minus 1. 1 square it is 1. 4 25s are 100. 100 it is minus 1. Minus 1 square. 1 minus 1 0. That means last 2 digits should be divisible by 4. Just by looking at the question, I should be able to say that answer last 2 digits should be divisible by 4. Why? Because 108 is divisible by 4. 4 9s are 36 minus 1 square 1. 4 25s are 100 minus 1 square 1. 1 minus 1 0. Suppose if the option is like this. Suppose if the option is like this. 2818. Just I am changing the digits. Whatever Madhu has said, you can say that 18 is incorrect. Why? Because left hand side is divisible by 4. Left hand side is divisible by 4. Left hand side is divisible by 4. Suppose, now see here. Suppose if there is an option like this. 2881. If there is an option like this, 2881. 108 is an even number. 35 it is an odd number. 99 it is an odd number. Odd minus odd, even. Even plus even, even. Answer should be an even number. Answer should be an even number. 2881, it is eliminated. If the answer options contain both even number and odd number, use the even and odd tree concept. If the answer option contains different unit digits, use the unit digit concept. If the answer option contains different last 2 digits, use the last 2 digits concept. If the answer options digital sums are different, use the digital sum concept. If none of these is working, go by the speed calculation method. Go by the speed calculation method. Simplification 2, simplification 3, simplification 4. After you attend all the 4 classes, you will be able to solve it very fast. It is an introductory session where I am giving you different ways of solving the question. Method 1, method 2, method 3. This method will work for this case. This method will work for this case. I hope the idea it is clear. Everybody kindly reply in case if you got a doubt. What I did, if there is an answer option odd, even plus odd, odd minus odd, even, I will eliminate it. If the answer option unit digits are different, unit digit, last 2 digits are different, last 2 digits, digital sums are different, use a digital sum. Third question, I hope the concept is clear. 30 seconds, I will see the live chart. Maybe some students might ask a very good question. I will discuss it in the live class. I hope the idea it is clear to all the students who joined the Arithmetic Live Plus recorded batch. In your batch, there are recorded videos folder and there is a live class folder. In the live class, we kept percentages, profit loss and discount, compound interest and simple interest. 4 videos we kept it. Shall I get into the next concept? Third one. Fourth one. Watch this class again and again. Then you will be able to understand the logic. Now see here. 97 into 11 plus 999 square minus 58. 97 into 11 plus 999 square minus 58. Do not jump to speed calculation directly. First thing is, it is an odd number. It is an even number. Let us do. Answer option contains both even and odd number. 97, it is an odd number. 11, it is an odd number. Odd into odd, odd number. 999, it is an odd number. 58, it is an even number. Odd plus odd, it is an even number. Even number minus even number. Even minus even, even. Even minus even, even. Answer should be an even number. This is an odd number. This is an odd number. Only 2 options we eliminated based on the number tree concept. Based on the number tree concept that we eliminated. Now if you see, here the digital sum is 999 out 1. Here also it is 1. Here also it is 2. Here also it is 3. So digital sums are different. Let me attack the question by using digital sum. Let me attack the question by using digital sum. Wherever 9 is there, I eliminate it. Wherever 9 is there, I eliminate it. 7 into 11 digital sum, it is 2. Minus 58. 5 plus 8, 13. 13, it is 4. 7 2s are 14. 5. 5 minus 4, 1. Answer digital sum should be 1. Answer digital sum should be 1. This is 2 and it is 3. So by using a digital sum, we eliminated few more answer option. We are stuck with option 3 and option 4. Last 2 digits are different. So here I used even and odd number concept and I eliminated few incorrect answer options. Here I used digital sum concept. Now I will use last 2 digits concept. Last 2 digits concept. Let me do it so that you will understand which all concepts I am using. Even and odd number, digital sum concept and the last 2 digits. And the last 2 digits. Now see here. Please do not waste. Do 97 into 11 last 2 digits. Do not do it. 97 into 11. Last 2 digits of a number. If I want the last 2 digits of a number, divide by 100. If I want the last 2 digits of a number, divide the number by 100. 97 divided by 100 minus 3. Minus 33. Negative remainder minus 33. Positive remainder 67. So these first value 67. 999 is 1 less than 1000. So it is 01. minus 58. 68 minus 58. 68 minus 58. Last two digits should be 10. So option number 3 is eliminated. Option number 3 is eliminated. I hope the idea it is clear. Again I am explaining, sir. Do not miss any of these 4 simplification videos. Right? In case if you miss it, then probably you will find it very difficult to do DI simplification, DI related problems. This is an odd number into odd number. Odd number. 999 odd number. Odd plus odd, even. 58 is even. Even minus even, even. Answer should be an even number. First option out. Second option out. 1 and 2 are eliminated because of number tree. Then digital sum, 9 out, 999 out, 7 into 2, 14, 14 it is 5, 999 out, minus 58, 5 plus 8, 13, 1 plus 3, 4, 5 minus 4, 1, answer digital sum should be 2, this is 2 and it is 3, out, last two digits are same, see here, 97 into 11, do not multiply and waste your time, 97 divided by 11, minus 3 into 11, minus 33, positive remainder will be 67. Positive remainder will be 67. 999. It is 1 less than 1000. 1 square 0 1. 67 plus 1. 68. 68 minus 58. Answer last two digits it is 10. Answer last two digits it is 10. Now try to find the last two digits. Find the last two digits for first one 6396 plus 5392, 6396 plus 5392, second one 6396 into 5392, third one 1372 plus 2397 minus 3789, last two digits, very very important concept, sir. Find the last two digits for 6396 plus 5392. Our entire concentration is on last two digits. Our entire concentration is on last two digits. Last two digits. 96 divided by 100 minus 4. 92 divided by 100 minus 8. Negative remainder minus 12. Positive remainder 100 minus 12 is 88. 100 minus 12 is 88. 96 divided by 100 minus 4. 92 divided by 100 minus 8. Minus 4 into minus 8. 32. Minus 4 into minus 8 plus 32. Idea it is clear. 72 divided by 100 minus 28. 23 divided by 100 minus 3 minus 89 divided by 100 minus 11 minus 31 plus 11 minus 20. Last two digits is 80. Last two digits is 80. I hope the idea it is clear, right? 96 divided by 100 minus 4. 92 divided by 100 minus 8. Minus 8 minus 4 minus 12. Positive remainder will be 88. Positive, instead of doing 6 plus 2, 8, 9 plus 9, 18. Please do not do that and waste your time. Convert everything into a simpler values. 96 divided by 100 minus 4. 92 divided by 100 minus 8. Minus 4 into minus 8. 32. 72 divided by 100 minus 28. 97 divided by 100 minus 3. 89 divided by 100 minus 11. Minus 31 plus 11 minus 20. Last two digits is 80. I hope the idea it is clear. I hope the idea it is clear. In case if you are thinking that I am right, next one. Cube root of 12167. Cube root of 274625. Cube root of 250047. Q50047. Just 1 minute, sir. Right? This is what the spam from the competitors hits me. Right? There are people who keep on writing the messages, right? So many times, right? Same messages. So many times, right? And students are smart enough to understand that it's a spam, right? Please try solving this question using the concepts which we discussed. Using the concepts which we discussed. Next one, try to solve, sir. Right? Cube the root of 12167 into cube the root of 274625 into cube the root of 250047. Cube the root of 250047. Now what we will do is, first we will discuss some concepts. We will discuss some concepts. We will discuss some concept. First thing is how to find the cube root of a perfect cube. How to find the cube root of a perfect cube. First concept which we will discuss. Second concept, how to identify whether a number is perfect square or a perfect cube. Perfect square or a perfect cube. These are very, very important concepts. First one, how to find the cube root of a perfect cube. How to identify whether a number is a perfect square or a perfect cube. How to apply, please write down, sir. How to apply digital sum. How to apply digital sum for perfect square root problems, perfect square root problems, perfect cube root problems, perfect square root problems, and a perfect cube root problems. These three concepts which we will discuss. Right? Now, next one. Last two digits for a perfect cube. Last two digits for a perfect cube. Once you understand these four concepts, then you can solve any of these questions. Cube the root of 12167 into cube the root of 274625 into cube the root of 250047. First one, see here, sir. 12161, it is an odd number. Cube the root of odd number, it is an odd number. Cube the root of odd number, it is an odd number. Cube the root of odd number, it is an odd number. Odd into odd into odd. Odd into odd into odd. Answer will be an odd number. Answer will be an odd number. Just by looking at the question, I am able to eliminate. This is eliminated and this is eliminated. Cube the root of odd number, it is an odd number. Cube the root of odd number, it is an odd number. Cube the root of odd number, it is an odd number. Odd into odd into odd, it is an odd number. Answer should be an odd number. First option eliminated, fifth option eliminated. Two options eliminated by using number tree. But before we discuss, let us see if we can eliminate any other answer options by using any other logic. Cube the root of 12167 into, what is the next question? Cube the root of 274625. 274625 into cube the root of 250047. 250047. 250047. Now listen carefully, sir. Odd into odd into odd, it is an odd number. Answer should be an odd number. Only few answer options which we eliminated. Now, next one. Let us take these example. Cube root of 32768. Cube root of 32768, it is 32. Cube root of 32768, it is 32. If I cube it on both the sides, 32768 equivalent to 32 whole cube. Are you all with me? How to use the digital sum for a perfect cubes we are listening. 3 plus 2, 5, 12, 18, 26. 2 plus 6, it is 8. 3 plus 2, 5. 5 cube, 125. 125, it is 8. Digital sum is equivalent for left hand side as well as the right hand side. So if there is a cubed root, cube on both the sides. But the first thing is, this will work for a perfect cube. Perfect cube. Now, how to check whether a number is a perfect cube or not? How to check whether a number is a perfect cube or not? I hope you are understanding how the digital sum can be applied for a perfect cube. How to check whether a number is perfect cube or not? How to check whether a number is perfect cube or not? Method 1. We will discuss as many methods as possible. Method 1. Suppose if I take a number, what will be the digital sum of that numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8 and 9. If I take 91, what is the digital sum? 9 plus 1, 10, it is 1. If I take 181, what is the digital sum? 1 plus 8, 9. 9 plus 1, 10, 1. This is the set of all the numbers whose digital sum is 1. This is the set of all the numbers whose digital sum is 2. This is the set of all the numbers whose digital sum is 3. Digital sum is defined as sum of the digits until a single digit number is obtained. Digital sum is defined as sum of the digits until a single digit. Set of all the number whose digital sum is 1. Set of all the number whose digital sum is 2. Set of all the number whose digital sum is 3. Set of all the numbers whose digital sum is 4. Set of all the numbers whose digital sum is 5, 6, 7, 8. Cube it. 1 cube 1, 2 cube 8, 3 cube 27, 2 plus 7, 9, 4 cube 64, 1, 5 cube 125, 8, 6 cube 216, 9, 7 cube 343, 1, 8 cube 512, 8, 9 cube 729, 9. Very, very important key points, sir. What are all the right hand side values we got? 1, 8 or 9. Very important point. If a number is a perfect cube, the digital sum will be 1, 8 or 9. Reverse may or may not be true. If a number is a perfect cube, it should be having a digital sum 1, 8 or 9. The numbers with digital sum 1, 8 or 9 may or may not be a perfect cube. Extremely important concept for to check whether a number is a perfect cube or not. Without checking, we cannot do this. What if inside the digital sum is not 1, 8 or 9? Then that becomes a non-perfect cube. Non-perfect cube, there is a method of approximation which I kept in the Anil Nair classes YouTube channel. How to find the approximate value of an nth root. Very, very important. How to check whether a number is a perfect cube or not. Digital sum should be 1, 8 or 9. Digital sum should be 1, 8 or 9. Please check the digital sum for the given values. 7 plus 2, 9 out. 6 plus 1 plus 1, 8. Okay. If it is not 1, 8 or 9, then it is not a perfect cube. 7 plus 2, 9 out. 10, 12, 17, 8. Right. 7 plus 2, 9, 5 plus 4, 9. If inside, if you got a digital sum other than 1, 8 or 9, then you cannot apply the cube root of a perfect cube logic. Then that becomes a non-perfect cube. Suppose he gave you cube root of 13 into cube root of 25 into cube root of 12. You cannot apply the logic which I am going to discuss right now. 13, what is the digital sum? 4. The digital sum of a perfect cube is always 1, 8 or 9. 13, it is 4. 25, it is 7. 12, it is 3. So this logic of applying the digital sum by cubing on both the sides will not work. By cubing on both the sides will not work. I hope the logic is clear. Kindly, blindly don't go ahead and find out the cube root. If a number is a perfect cube, the digital sum should always be 1, 8 or 9. 1, 8 or 9. Now see here. If a number is a perfect cube, digital sum should always be 1, 8 or 9. 1, 8 or 9. Reverse case may or may not be true. May or may not be true. If a number is a perfect cube, the digital sum should be 1, 8 or 9. Another very important concept. If a number is a perfect square, digital sum should always be 1, 4, 7 or 9. Digital sum should always be 1, 4, 7 or 9. Reverse may or may not be true. Reverse may or may not be true. I hope the idea it is clear. This is one of the methods to tell that this number is definitely not a perfect square. This number is definitely not a perfect square. Definitely not a perfect square. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is it a perfect cube? Is this number a perfect cube? 1, 2, 3, 4, 5. Is this number a perfect cube? 4 plus 5, 9 out. 3 plus 2 plus 1, 6. If it is a perfect cube, the digital sum should be 1, 8 or 9. So answer for this question is no. Answer for this question is no. Sir, how you got 1, 4, 7 or 9? Same logic. The digital sum of a number is always 1, 2, 3, 4, 5, 6, 7, 8, 9. Cube, 1 cube 1, 2 cube 8, 3 cube 27. 3 square, right? We are doing 1 square 1, 2 square 4, 2 square 4. 2 square 4, 3 square 9, 4 square 16, it is 7. 5 square 25, it is 7. 6 square 36, 9. 7 square 49, 4. 8 square 64, 1. 9 square 81, 8 plus 1, 9. That is the reason we got every perfect square has a digital sum 1, 4, 7 or 9. Every perfect square digital sum should be 1, 4, 7 or 9. Every perfect cube digital sum should be 1, 8 or 9. Every perfect cube digital sum should always be 1, 8 or 9. Concept is clear? Now let us solve this question. What is this question? Then we will do the cube root. Question is cube root of 12167 into cube root of 274625 into cube root of 250047. What are all the important properties that we discussed? How to identify whether a number is a perfect square. Perfect square digital sum will always be 1, 4, 7 or 9. Perfect cube digital sum will always be 1, 8 or 9. How to apply digital sum for perfect square or perfect cube. In second, some more properties are there, we will discuss. How to find the last two digits for the perfect cube. How to find the last two digits. Let me explain that concept. Cube the root of 13824. Cube the root of 13824. Suppose if the options are 22, 24, 21 and 18. Cube the root of 13824. It is 22, 24, 21 and 18. Listen carefully, sir. Another beautiful concept. Suppose there is a number unit digit. What are all the unit digits that can be possible for a number? Number unit digits are 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all the possible unit digits. Let me cube it. 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, 6 cube 216, 7 cube 343, 8 cube 512, 9 cube 729. 9 cube 729. Cube the root of 13824. We are finding it. First we will understand some beautiful similarity between a perfect square and a perfect cube. 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, 6 cube 216, 7 cube 343, 8 cube 512, 9 cube 729. A perfect square never ends with which all logic? A perfect square never ends with 2, 3, 7 or 8. A perfect square never ends with 2, 3, 7 or 8. Only these numbers which are 2, 3, 7 or 8. On cubing I am getting a different number. 1 cube it is 1. 4 cube it is 4, 5 cube it is 5, 6 cube it is 6, 9 cube it is 9. A perfect square never ends with 2, 3, 7 or 8. 2, 3, 7 or 8 on cube. I am getting a different number. What is that number? A perfect square never ends with 2, 3, 7 or 8. नीचे से ऊपर लिखो sir. 2, 3, 7 or 8. Are you with me? 2, 3, 7 or 8 on cubing, it is 2, 3, 7 or 8 from bottom to top. Or in simple language, 10 minus 2 it is 8, 10 minus 3 it is 7, 10 minus 7 it is 3, 10 minus 8 it is 2. 10 minus 8 it is 2. A perfect square never ends with 2, 3, 7 or 8. Only 2, 3, 7 or 8. Only 2, 3, 7 or 8. On cube it ends with 8, 7, 3 or 2. A perfect square never ends with 2, 3, 7 or 8, 2, 3, 7 or 8 on cube. It ends with 8, 7, 3 or 2. It ends with 8, 7, 3 or 2. I hope it is clear. So it is ending with 4. It is ending with 4. Question unit digit should be 4. These you can eliminate. 22, 21 and 18. By using unit digits you can eliminate. A perfect square never ends with 2, 3, 7 or 8. Only 2, 3, 7 or 8. On cube I will get another unit digit. That unit digit is the tens complement of the question unit digit. 10 minus 2, 8. 10 minus 3, 7. 10 minus 7, 3. 10 minus 8, 2. A perfect square never ends with 2, 3, 7 or 8. This is a unit digit way of looking at the answer. This is an unit digit way of looking at the answer. Now see here. But the problem is all the unit digits here are same. All the unit digits here are same. Suppose if the answer it is like this. Let me keep one option. 78956. 78956. If the option is like this, anyway it is an odd number, so 6 is out because it's an even number. It is 7. 7 means what will be the unit digit? 7 means 3 cube is 27. 7. A perfect square never ends with 2, 3, 7 or 8. 10 minus 7, 3. 10 minus 5, 5. 10 minus 7, 3. 9 5s are 45. Unit digit should be 5. 3 options are 5. If there is any other answer option other than 5, that can be eliminated by using the unit digit. That can be eliminated by using the unit digit. I hope the concept is clear. Every question I am going deep dive into it. 100 feet down analysis I am doing, so that even if the question nature changes, you should be able to solve. In case if you do not want cube the root of 12167, cube the root of 274625. So what are all the concepts that we discussed? We discussed how to apply digital sum for a perfect square. This I will discuss right now. Third one. So fourth also we will discuss. Third and fourth point in detail we will discuss right now. Not interested in solving this question, right? You make it as 635. Both the options are same. Similar to an CMAT entrance examination where the answer options will be same. Right, now let us see how to apply digital sum for this one, how to apply last 2 digits for perfect cube. I hope this concept is clear. I hope the concept it is clear. So what are all the concepts we discussed? Unit digit we discussed. Now let us see the digital sum concept. Digital sum concept. How to use the digital sum. How to use the digital sum for perfect square roots. How to use the digital sum for a perfect square root. How to use the digital sum for a perfect cube root. Perfect square root and perfect cube root. Now see here. Listen carefully, sir. Let me take this number. Cube the root of 13824, we wrote it as 24. Cube on both the sides. 13824 equivalent to 24 whole cube. Let us see whether the last 2 digits are same. Definitely it is same. Why? Because 24 power odd number, last 2 digits is 24. Already we discussed in the last 2 digits logic. 24 power odd number, it is 24. Suppose if it is cube the root of 3375. If the answer is 15, this will become 3375 equivalent to 15 whole cube. These 75. It is 15 into 15 into 15. Odd 5 into odd 5. 25. Odd 5 into odd 5. Last 2 digits 25. 1 is an odd number. Even 5 into odd 5. Last 2 digits are same. Last 2 digits are same. I hope the idea it is clear. Cube on last 2 digits. Cube the root of 3375. 3375 equivalent to 15 whole cube. 3375 equivalent to 15 into 15 into 15. Last 2 digits is 75. Odd 5 into odd 5. 25 into 1 5. Even 5 into odd 5. Last 2 digits it is 75. Last 2 digits it is 75. This is for the cubed root. For a perfect square root. Suppose if it is 7744 equivalent to 88. So 7744 equivalent to 88 whole square. 88 whole square is 12 less than 100. 100 minus 12 square. Last 2 digits is 12 square. 12 square is 144. It is matching. Last 2 digits it is matching. Not a single doubt you will get in any of the classes which I am taking. Right? Any doubts are there in the live class, mention the doubt then and there itself. If I think that I need to create a question, I will create a question on spot and I will explain you. Right? 7744 is 88. Square root on both the sides, it is 88 square. 88 square is 100 minus 12 square. 12 square it is 144. Last 2 digits are matching. Idea it is clear. Now, how to find out the square root? Let me do some more questions. Some more questions so that you will understand it very easily. Square root of 5329. It is 73. 77, 75, 69. Square root of 5329 equivalent to 73, 77, 75, 69. 75, 69. 5 plus 3, 8. 8 plus 2, 10. 9 is out. 10 digital sum is 1. A perfect square digital sum will be 1, 4, 7 or 9. 1, 4, 7 or 9. Let me take first option. 5329 equivalent to 73. Square it. 5329 equivalent to 73 square. 73 is 50 more than 23 more than 50. 23 square is 529. Last two digits it is matching. Last two digits it is matching. 77 square. Wantonly I kept 77 square. It is 100 minus 23 square. Last two digits it is matching. Two options, last two digits matching. 75 square. Odd 5 into odd 5. Last two digits 25. 69 square. 50 plus 19 square. It is 361. Two options are eliminated based on last two digits. Two options are eliminated based on last two digits. 75 square is 5 5s are 25, add 1. 5625. 5329 is less than 5625. 77 square cannot be the answer. Answer for this question is 73. Answer for this question is 73. How to use the digital sum concept or the last two digits concept? You can use digital sum also, sir. 5 plus 3, 8. 8 plus 2, 10. 1. 73. 7 plus 3, 10. 10 it is 1. 1 square equivalent to 1. 7 plus 7, 14. 14 it is 5. 5 square 25. 2 plus 5, 7. Not matching. You can use digital sum logic. You can use last two digits logic. You can use the generic speed calculation logic. I hope the concept is clear. Square root of 5329 equivalent to 73. 5329. Watch this class second time, third time. In every problem you will write some more new innovative key points. I hope this concept is clear. One more. Square root of 80 to 81. Square root of 80 to 81. 91. 93. 95. 99. 99. 91. 93. And 95, 99. Directly you can say 80 to 81. If I remove the squares, 91 square, 93 square, 95 square and 99 square. 99 is 1 less than 100, 0, 1. It is 5 less than 25. 7 square 49. 9 square 81. Last two digits it is matching. Answer is 91. Answer is 91. I hope the idea it is the